what I'd like to do is to just highlight a few selected issues, mainly pertaining to water quality today, that are coming out of some of our ongoing studies that we're conducting. Again, as I mentioned, we've been out conducting these studies for about the last 12 to 13 years. And our aim has been to, number one, just build a good data foundation to help us understand better what is actually out there on the ground, in the water, in terms of understanding the major characteristics that define the system. We've also been trying to develop some tools that we can use based upon that data to help us project what could be if we were to intervene in different ways by improving management or engineering some new structural alternatives to the way we control water. We have attempted to use that database and those models to characterize the stream aquifer system from the perspective of understanding flows and also water quality. And our last aim is to evaluate again alternatives for trying to bring about some improvement to the conditions that we see out in the field presently. So today, my talk is going to focus on water quality, and we're going to speak specifically to water quality in the main stem of the river itself, although we will brief you a little bit on our broader activities that have led to some of the data that I'll share with you today. We have been studying the basin primarily down in the lower portions of the watershed below Pueblo, but in more recent years we have begun doing some data collection up in the upper basin. So we have an area up in Chaffee County that we've been working on. In the lower and in that basin, upper basin area, we have quite a number of groundwater monitoring wells that we've drilled and that we take measurements in. We also have a number of surface water locations in tributaries as well as the main stem where we take flow measurements and water quality sampling. The red triangles on the slide there indicate the positions along the river where we take the samples that I'll be sharing with you today. In the lower Arkansas River Basin, we have two study sites. The first extends from west of Manzanola through Rocky Ford and La Junta and almost to Las Animas. And we've been working there since 1999, gathering data. And then since 2002, we've had a study region that extends from west of Lamar all the way to the state line. In the what we call our upstream study region around La Junta and Rocky Ford, we have again about 100 locations spread out over the landscape where we monitor groundwater in the system. And then we also monitor surface water at dozens of sites within the main stem of the river, the tributaries, drains, and canals that serve the irrigated lands of the region. Again, the red triangles show you the locations along the river where we have been taking samples and where we will focus our attention today. We have been monitoring groundwater as well in the lower portion of the lower basin between Lamar and the state line. Again, about 100 or so monitoring wells down there. Also many surface water locations where we gather data in the field, including the locations along the river that are indicated there. As far as the type of groundwater data that we routinely gather, we gather data on the depths to the water table at these locations at various frequencies, taking most of our measurements during the active part of the season, the irrigation season, but also during the off-season. We measure groundwater quality, a number of what we call in situ or in place measurements that we make with probes pH, dissolved oxygen, oxidation reduction potential, electrical conductivity, which is an indicator of the total dissolved solids in the water, as well as temperature. We also gather samples periodically out of our groundwater wells that we run through the laboratory to analyze for total dissolved solids, the major components of the salt ions that make up those total solids. One of the key ions of concern being sulfate. We look at an issue that has risen in recent years and has a lot of attention today in the Arkansas Basin because every one of our river segments are impaired in the lower basin for selenium. We also are looking at uranium, which is seems to be a growing constituent of some concern. We're looking at nitrate, as well as other elements that we have studied primarily in the upper basin to try to understand what elementary or what trace elements may be present in the form of those types of metals that we might expect to be present due to mining operations in the upper basins. We've done some studies related to those constituents as well. As far as surface water data, again, stream flow rates. We've done a lot of measurements of irrigation practices out on the field, measuring water applied and trying to understand where that water goes. Canal seepage measurements along a number of canals. Surface water quality measurements are very similar to those that we take in the groundwater that we just mentioned. The major non-point source concerns that I want to focus on in this brief talk with you today is number one, total dissolved solids. It's of major concern primarily to agricultural production. As salt concentrates, plants become more and more unhappy. They're not able to as easily extract the water they need from the soil pores when there's a lot of salt present in that water. Another big element of concern that we just mentioned is selenium, and we care about selenium concentrations primarily because of the impact that they have on aquatic life, but in the groundwater, selenium can rise to levels that are damaging to livestock health as well. Uranium is of concern for drinking water, although we don't have any numeric standards along the stream right now. It is an issue of growing problem. Nitrate ties back to one of our earlier panels today. It's one of those nutrient constituents that is getting a lot of attention, and it causes problems related to drinking the water, but it also causes oxidation of other elements and causes the concentration of those elements to be greater than they would be otherwise. And we'll talk a little bit about that as we go along. In terms of the processes that take place to create what we call non-point sources of water quality problems in our river basin, what happens is we have water diverted out of the river into canals along the river, and here I'm showing some constituents that we've been giving attention to. Nitrate, sulfur in the form of sulfate, primarily selenium and uranium. The water goes into the canals with those dissolved constituents. It's applied to the land by irrigation. And as it comes onto the land, it comes on through the irrigation water where it's already dissolved, coming in from upstream into the canals. But then additional fertilizer is applied primarily in the form of ammonium. And so we get nitrification. The nitrogen turns into nitrate from the ammonium, as well as the nitrate that was coming in from the canal water. Sulfur, selenium, uranium move down through the profile into the groundwater, and that makes its way into the alluvial aquifer that underlies the whole system. But that material also comes out of the canals as it seeps out of the canals into the alluvial aquifer. We have water then coming up back into the soil by upflux from the really shallow groundwater that underlies most of the alluvial soils in the basin. Then the evapotranspiration occurs, which further concentrates those solutes that are left over. Then we have a nitrate that comes down in the water in contact with the shale that forms the bedrock that underlies the alluvium. And there are pyrites inside that shale that when that oxygen in the nitrate comes in contact with that pyrite, it drives selenium and uranium and sulfate out of that pyrite, adding additional constituents to the water, which then makes its way back through the aquifer, and the whole cycle starts over again. Now you can imagine this happening several times as we move further down the river and continue to evaporatively concentrate, dissolve, and move more and more materials back into the river. Inside the river itself, we're studying processes that can affect concentrations. This material that comes in, part of it will actually be absorbed as sediments that are suspended, as well as those in the bed of the river. Some of it will precipitate out, depending on the chemical conditions, and some of it will actually volatilize. It'll go up in a gaseous form out of the river. So we're trying to understand how this all affects what will make its way further downstream and start this cyclic process all over again, thereby increasing concentrations even more. Just to show you a little bit of data here quickly, as far as total dissolved solids, this is going from left to right, positions along the river where we've been gathering data for a number of years now. And this is in our upstream study region, again around Rocky Ford and La Junta in that vicinity. And as you go from upstream to downstream, you notice that the total dissolved solids, as you would expect, are increasing. Now that red band indicates an estimate of the maximum levels, which of course vary depending on a number of considerations that influence this, but they estimate sort of a danger zone in terms of the maximum levels that we can tolerate before productivity will be affected in terms of irrigation water. And you can notice that as we move along the stream, we're getting into and well above that zone in terms of the effect of salinity. Now we move downstream of John Martin, extending from around just east of John Martin there all the way down to the state line. You notice that salt has become a major problem. And in fact, what we estimate from a recent study we just completed is that we're losing, on the average, about 6% of our productive potential in the upstream region around Rocky Ford, and about 15% of our productive potential in the lower part of the basin as a result of salt accumulation alone. Just to put it in perspective a little bit, we're blessed with some of the greatest water in the world when it comes out of the mountains. If you look at these data here in the upper portion of the basin up there in Chaffee County, the data hardly even show up in terms of concentrations of total dissolved solids. Selenium, the red line indicates the chronic standard for aquatic life. And this is in the upstream portion of the lower basin, and you can see that at every river location we have major problems related to selenium concentrations in the river. By the way, these boxes that you see plotted at each point indicate sort of the range of values that we've measured for the constituents over time. As they vary seasonally and year to year. The upper portion of the box would indicate a level that would be exceeded only about 15% of the time, and the outlying whisker, so to speak, on the upper portion is the maximum value we ever measure. The lines in the middle are the mean values, but you can see that even the low values typically exceed the chronic standard for selenium. Now, if we look at data downstream, we also have a growing problem with selenium, but it's interesting, all the way there to the left, You see data that we've begun to gather just recently at a location just downstream of John Martin Reservoir. And John Martin plays a really important role in the system in mitigating water quality. We still don't fully understand all that goes on in terms of chemical reduction processes, precipitation, volatilization that's going on. But one thing you notice when you look at concentrations of selenium coming out of John Martin, they go way below the chronic standard. And it doesn't take very long before they're back up again. But we do see John Martin as being an important dampening element to the system. Uranium, again, you can see the increasing uranium concentrations compared to a nationwide standard for drinking water of 30 micrograms per liter. We're exceeding that at every location in the upstream region. In the downstream region, it's far worse. And as you can imagine, Kansas is quite concerned about the uranium that is coming across the state line. Again, you look at uranium in the upper basin, and surprisingly, it's getting down in the lower end of Chaffee County, close to that line that's shown. Actually, that line is incorrect. It should be higher than that. But again, the uranium is just a non-issue right now in the upper basin. Nitrate, just to give you an indication here, along the upstream portion of the lower basin, this is a plot of nitrate concentration compared to a nationwide standard. Again, we don't have numeric standards in place right now along the Arkansas and the lower part of the basin, but that red line is a 10 milligram per liter standard. Now that's as nitrate, not as nitrogen, Nancy, and I think it would be somewhat comparable maybe with the numbers that you were quoting. And so you look at nitrate and you can see that the means are below this nitrate standard, but we do get exceedances, somewhat, fair number of exceedances along the river. Again, interesting in the portion of the river downstream of John Martin Reservoir, the nitrate concentrations drop dramatically. And we do think, again, that the reservoir plays some role in mitigating nitrate concentrations, even more so than selenium. Again, upper basin, nitrate is a non-issue so far. So, whoops. Just real quickly, we are spending some time analyzing how we might go about improving the system, and we do think that there's some real potential for bringing about marked improvements in concentrations. One of the things we're looking at is what would happen if we could move to higher irrigation efficiency practices out on the land. Another is sealing our canals. There's a tremendous amount of water that moves out of the hundreds of miles of canals that traverse the contours of our valley, and they're supplying a lot of water to the underlying aquifer, moving that water through the shales and the weathered shales, picking up additional materials. And we think that if we could effectively seal those canals and cut down on that seepage, it could have a big impact. We've also been looking at enhancing fertilizer management. Because of the role that nitrate plays as an oxygen source, we believe that if we could significantly lower nitrate, that we could see a marked reduction in concentrations of selenium, sulfate, and uranium, all of which are sensitive to these oxidation reduction reactions that drive them out of the geologic materials, but also keep them in solution as long as that oxygen is present and keep them from precipitating out or absorbing. So in summary, we've got some major, the major non-point source processes that are going on a daily basis along the river that are contributing to high total dissolved solids or salts, selenium, uranium, and nitrogen concentrations. This is due to excess deep percolation and seepage flows. It's due to evaporative concentration that occurs because of vast quantities of water vaporizing through the irrigated cropland that's spread across the landscape. And then it's due also to these oxidation reduction reactions that are tied to a great deal to fertilizer applications across the valley. TDS concentrations are reducing crop yields markedly in our valley, and we believe that if we could get a better handle on how to control those concentrations, we could see crop yield production go up. Selenium concentrations, again, are substantially in violation of aquatic life standards, and this remains a big challenge for our state. We have high uranium and nitrate concentrations in relation to nationwide drinking water standards, and I believe it's going to have to be given closer attention in the days and years to come. And then lastly, the use of our models that we've developed based upon the data that we've been gathering and the analysis that we have conducted today do indicate to us that there are some real promising prospects for decreasing concentrations in our waterways that make up the Arkansas Basin through the implementation of some best management practices that we do think could have some marked influence on the conditions out there in the field.